How are you, my friend?
I'm great, thank you.
Ready to go?
Yeah.
All right, go for it.
I love archery. Draw, anchor, and release. There is no better feeling. And the best part is, archery is open to everyone. It is inclusive of all ages, genders, and abilities. When I toured blind schools, I learned that the blind love archery as well. In fact, archery for the blind is becoming a Paralympic sport in the year 2020. However, there is a problem with this amazing sport. When I practice alone, I find it really difficult to incorporate my coach's feedback since I don't have his guidance. I found that many fellow archers had the same problem. I wanted to solve this, so I created Drona, an archery assistant with an interface for the visually impaired. Existing solutions are expensive and inadequate. For example, this tool that solely measures how much a user is pulling their bow costs up to $2,000. Existing mechanical accessories run into thousands of dollars and do not give form corrections. My solution gives real-time form corrections, shot corrections, scores your target board, and costs less than $30. Drona has 5 major components. 1. A flex sensor with an Arduino Nano to measure how much a user is pulling their bow. 2. A gyroscope to sense the direction of the shot. 3. An accelerometer to sense the elevation. 4. A 3M armband that I am currently wearing right now to give arm posture corrections. And 5. A mobile app that I created that processes all this data using mathematical formulas and machine learning. It runs on the user's phone attached to the bow and gives continuous, real-time corrections. Drona began with a handcrafted paper bow with a flex sensor taped on. I then started to use my professional bow with my app. I included several more factors in a shot and added many more features to Drona, such as the machine learning for improved form and the image analysis to score your shots. The first stage of my app is a one-time bow calibration phase. I use a spring scale with a built-in tape measure to measure the draw length with the corresponding draw force. This represents Hooke's law as shown in the graph below. The slope of the line is K, or the spring's constant, which depicts the quality of the bow. Originally, I used a commercially available flex sensor, but it didn't give me the range I needed on my bow. I innovated my own flex sensor using 3M materials with the Velostat as a base. The Velostat is a flexible, resistive plastic, so when you bend it, the conductive ink particles come closer together, which reduces the resistance. This gave me a huge range. I connected my flex sensor to a voltage divider circuit. As you can see highlighted in red, the more the bow is bent, the lower the flex sensor's resistance. In the second calibration phase, the user enters the user's shoulder height and the arrow's mass into the app using Siri dictation. The final calibration phase is for the shooting range. The user enters the height of the target, the distance to the bullseye, and the wind velocity. Here is a quick demonstration of my app.
Aim left. Aim lower. Your pull is perfect. Gyro is perfect.
I use Google's Inception model and transfer learning to train Drona's image classifier with hundreds of images of target boards with different arrow combinations. I got accurate results to the first 3 arrows with a 98% certainty. I spoke to many distinguished archery professionals. We're all very excited about my project. Mr. Diaz, a firefighter who lost his vision in the line of duty, then began to teach archery and physics, quoted that my innovative application would be a transformative addition to the visually impaired community and society at large. I'm super excited to attend the Abilities Expo, where an international visually impaired archery gold medalist will be using Drona. I'm also excited to collaborate with programs like the National Archery in Schools and the Wounded Warriors Project. And for tinkerers like me out there, you can assemble Drona using my live DIY YouTube channel. I would like to thank my mentor, the Discovery Education 3M Young Scientist Challenge, and all of you for making this possible. And I'm so glad that what started out addressing my passion for archery can impact so many people. Thank you.
That was an amazing presentation.
Thank you.
It was absolutely awesome. So it's kind of just a question that I got interested in, but tell me the story behind the name of your product.
Oh, yeah. So this is a very interesting name. Some of you may know about him, but Drona is an archery coach, actually the greatest archery coach of all times in Hindu mythology. So he coached Lord Arjun, who is also like an archery legend, the best archer of all times, and he trained him to defeat the opponent's side, the Kauravas. So he's sort of like a legendary figure in Indian mythology.
That was amazing. Thank
Thank
you very
you.
much. I'm wondering about the. I would think that it would be hard to shoot your bow the way you're used to doing it when you add something to it like that. Does that affect your shooting at all when you're putting your phone or the pieces of your invention onto it?
So when you shoot with accessories, which are very expensive, it tells you, it's basically showing you like how much to pull back using the flex sensor and where to aim using the sight. So this is essentially doing the same thing, but more efficiently with a lower cost and to a bigger extent. So it didn't feel unnatural or anything for me because it was giving me feedback, telling me how to aim or how I should correct my form. So it didn't feel unnatural at all, and it was easy for me to adjust when I was switching back and forth.
Could you go back to the slide with your equations on it?
Yeah.
I was wondering what D and G and some of those terms were. Could you try to explain that further?
Yeah. Yeah, so I entered this formula into my Swift code with much difficulty. It was very long. But so the user enters a few of these components or parameters into the app in one of the calibration phase you can see here. It's the final one before the game. So it fills in the parameters like height and the D distance, and the gravity is a constant 9.81 meters per second. So basically, I'll just explain some of these variables in more detail to answer your question. So the H is the height difference between the user's shoulder height and the target. So it would be very different optimal launch angle if I was shooting versus somebody who was 7 feet tall. Like I would have to aim much higher than them because I'm super tiny. But and the distance is a distance to the bullseye. So this is entered in every game because some people can switch. And the V is the velocity of the arrow, which is computed by my app in the hook slot stage. So it computes this using the potential energy and other things.
And you have wind speed listed up there, but that's not in the equation, is it?
So the wind speed, what I do for that is after I calculate the velocity of the arrow, I subtract the wind velocity from that and then compute it using this formula. Yeah.
Can you talk a little bit about how your 3M mentor helped you in this process?
So Miss Candice Bohannon was a huge help in my process. So one of the main things that she helped me with was the image analysis. She's an expert in those kind of things. So now my app can score different shots up to the first 3 arrows, and I completely have her to thank for that. And she also helped me with other problems like finding the correct 3M materials to use for this in many different aspects of my project, and she encouraged me to continue different aspects like the machine learning as well and to perfect my app. And yeah, so she was a huge help. Thank you.
Sriram, wonderful job. What are some other applications to your app?
Okay, so basically, like, what does it do? Oh, yeah. So my app can be used not only for archery, but in the future for many different sports. I can extend it to that because if you think about it, the trajectory and the projectile motion physics is the same for many sports, practically all ball games. Like a basketball, it's going in an arc into the basket, soccer into the goal, and for lacrosse, like into the hoop, for golf, like in a trajectory again. So I would have to tweak a few things like how to measure the potential energy, which in this case I'm doing with a spring scale. But after that, the physics is basically the same, so it wouldn't be that hard to extend it to other sports and give feedback on those as well. Thank you.
You did a really nice job. Feeling good? Mm-hmm. That was really great. I love it. So we're going to have you head out this way as they give you one more round of applause.